In this video, we'll have a look at how to delete more than one object using only one API call. Remember, on the free plan, we are limited to 60 API calls per minute. So this could be really helpful if you want to delete, let's say, 300 objects or maybe clear out a whole table. This could really help you to only use one API and then delete all of the objects inside of a table. Another thing that we're going to look at is also to retrieve more than 100 objects from your table. Well, that's going to use a few API calls, but I'll show you how to collect, let's say for one table that can store 1000 objects, how to collect all 1000 of that object. So the first thing that I'm going to show you quickly is I've just added one new field to my person class, which is the number field. And that's just to create some objects and to sort them and so forth. So what I want to do now is if we go back to data browser, you can see that I have nothing in the person class or in the person table. So in the person class also at my project, you'll see that I've included an int number there. And I've got the getter and I've got the setter for it. So from the previous video, that's basically what changed. Now in my main activity, I've just created two buttons there at the top that says delete all person objects and retrieve more than 100 objects. So we'll look at both of those, and then I've got a list view. So when we retrieve more than the 100 objects, we'll show them there in the list view. So I've got a button called btn delete. I've got a button called btn retrieve, and then a list view called lv data. And in the main activity, I've set them up. There's btn delete, retrieve, and the lv data. And there you can see I've set up all three of them. And there's the delete and the retrieve buttons. And then in my application class, I've got a method that I've created there to just quickly create 300 objects so that we can test this. So obviously we won't add something like this in our application. This is just for testing purposes. So basically I've created a static method to create 300 objects. And what I did there was to have a surnames array and a names array with some values in it. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 surnames and 10 names. And then I use the random class to basically create random objects with a random surname from the surname and a random name from this names. And then I'm setting that number field as well to start with 1, 2, 3 up until 300 there. Okay, and then I go to Backendless and I save the new person object. So let's run this quickly to just create 300 new objects just to see if we can test that out. So you'll see the application is running now. So if we go to Backendless now, you'll see it's now busy creating that 300 objects. And there we are. We've got all 300 objects. If I refresh, it's 300 objects. So it's just random surname, name and surname, and then a number from 1 to 300. So there's the surnames, there's the names. So we've got 300 objects now in this table. So let's say that we want to clear out this table. We want to delete everything in this table now. How will we do this? So in the main activity, I'm going to create an async task to basically run this in the background. So I'm going to say private class. And we're going to call this one, let's say, delete bulk from backend. Something like that. You can obviously call your class whatever you want. So I'm going to say extends async task. Now remember that the async task runs in the background on a different thread than your main user interface thread. So for the first part, I'm going to say void there because we're not going to pass anything to this specific async task. And again, void because I'm not going to use a progress bar showing the progress of how far we are. And then the last one, I'm going to save the exception. So that's what my doing background method will basically return back for me, will be my exception. Okay, so inside of your delete bulk, sorry for the spelling mistake there, bulk from backend, I'm going to go to code and override methods. I will need the onPreExecute method first. Then we'll need to go to override methods again. We'll need the doInBackground method. And after doing background, we will need the onPostExecute method. Okay, so these are the methods we use. And if you remember from the async task on a previous video that we did, the onPreExecute is still part of the user interface thread, as well as onPostExecute. But when we go to do in background, that's part of a different thread. So calling this class, this async task, will first run onPreExecute, then it goes into the background with on a different thread. And when it's done in the background, it goes through and goes to onPostExecute. So that first void there is anything that we pass in, and that will also come to do in background. So we're not going to pass in anything. The second void there is for a progress bar or a progress update. And then the exception, the last one that we pass in, is what your do in background method returns. And remember, it returns to the onPostExecute. So now normally in your onPreExecute, you'll start showing a progress bar here. And it could be just the simple turning progress bar. So I'm just going to say process started. Let's say, please wait. So that would be something like your progress bar starting showing. And then obviously in your onPostExecute, you can say you should dismiss that specific progress bar. So I'm just going to say something there like toast process completed, or whatever you want to do there. Okay, so that's just simulating your progress bar. So you'll start showing your progress bar there and dismiss it here. Remember that you can't show it inside of your do background or update your graphical user interface or your main user interface thread directly from your do in background. It must be done in onPost or onPreExecute. Okay, so then inside of my do in background method, what do we want to do here? So for this to work, we're going to say HTTP, and there's a URL connection, HTTP URL connection. And I'm going to call this one URL connection, whatever you want to call it. And I'm going to set it to null right from the start. We'll change it now. And then I'm going to also have an exception object. Let's just call this one exception, and we set that one also to null. And you're going to see why I'm using that one. You can see that we're sending through an exception, so that will be the one that I will actually be sending through or returning from this method. Okay, so now what we want to do is we're going to use a try and a catch block to run a specific URL connection. So I'm going to say catch there. And the class that I want to catch, or the exception I want to catch, is a malformed URL exception, which is that one there. And let's call it E. And now what we want to do here, because we can't show this exception now on a toast if it's thrown. So that's why I've got this exception there. So I'm going to say that exception there should be the object E. And that will help me then to catch that specific exception. Okay, so we've got a problem there because we haven't actually tried doing anything in the try block that will be able to throw that sort of exception. And then I'm just going to catch also the general exception. Let's call it also E. And then if it goes to that exception, we will set that one also just to E. Okay, and then we can have a finally block there, so which will always execute, and I'm going to say URL connection dot disconnect, and that will just disconnect my connection as soon as we start running that connection. Okay, so now in the try block, we're going to say URL, let's say URL again, equals new URL. And now the URL we're going to use there, I'm going to show you now where we'll get that URL. So we're going to make a connection, and we're going to say URL connection equals, and we're going to cast this to an HTTP URL connection. On that URL object of ours, we're going to say open connection, and that opens up the connection. Now, I think before we carry on, let's just see which connection do we need to open up. So if you go back to the website quickly, you can go to your REST console, and in the REST console, you'll see that there's a request URL. So we're going to change this one now a bit. So we're going to set the page size here to 100. We're going to set the offset to 0. And let's say I want to delete all of the objects in person now. If I quickly go to Data Browser, I could do something like delete everything where the name field is not equal to, let's just say, a J there, because you know that you've got full names there. So saying something like where the name field is not equal to just a simple J, lowercase, will actually do the thing. So what I'm going to do here is to say where the name field is not equal to, and in normal quotation marks, J. And you can see that, very important, you must choose bulk operation now. So you'll see this request URL changes the whole time as I'm typing something. So it's building up a URL for me, which is the one that we're going to connect to in coding now. And then if I say, you can see there's 300 objects. If I say delete now, it's executing the delete. And you can see 300. Now I've got nothing in that table anymore. So we know that this URL with the data that I've specified actually deleted now everything in that table. So if I go to my data browser now, you can see it's empty. So just test your URL there with the bulk operation and see if it actually deletes everything in your table. And now we want this URL, and this is the one that we need in coding. So after you've tested and everything is working fine, copy that URL. So then we go back to our coding. And that's the URL. That's the link we're going to use there. So it's a very long link, but you paste that link in there. That's the one that we want to make a connection to. So that's what we want to make a connection to. We open that connection, and then we need to set a few properties on that connection. So we're going to say URL connection dot set request property. And you can see it's a key and a value pair. So the first one that we want to have there is the application ID. The second argument will be your application ID. So we're going to get that now from the website again. So we're going to say URL connection again dot set request property. Again, the key will be secret, and this must be spelled exactly like I'm spelling it now. That will be secret key. And then the key. So we're going to get to that key now. And then again, URL connection dot set request property. And we're going to set this property application type. And the application type must be REST, all capital letters. So you remember that when we try to delete here, it's in the REST console. So we're trying using the REST service here in order to delete. So we're going to say set request property to application type should be REST. Then URL connection again dot set request method. And the method we want to use here is the delete method. So we want on that URL, we want to run the delete method. Why do we have the application key, the secret key? The application key and the secret key is there to authenticate us to actually run this delete function or whatever, and then we're just telling it we're using REST code to do this. And then we're just going to say URL connection dot get input stream, and then we're going to say URL connection dot connect, and that makes the connection and deletes everything in my table. Okay, so very important, you need your API, your link for your REST, from your REST console, and then we open up the connection, we authenticate this specific call, the type will be REST, the method is delete, and we connect. That actually is doing it for us, and then if everything went fine, the finally block will disconnect the connection again. Okay, so let's just go back and quickly get some values there that we need in the coding. So we need to have the application ID. So I'm going to copy that application ID, and that's the first one there that we need. And you can also see it's that first one that's part of your link. There it is. So we could have actually just copied it from there. And then if you go to the site again, The second one we need is the REST API key. So now it's not the Android API key. So it's the REST API key, and I'm going to copy that one, and you'll see it's the same as in that link at the top. You can see also from there, it's that same key. Okay, so this is now used to authenticate the application. So remember what we did. In the on pre-execute, it will say process started, please wait. Makes the connection, authenticate, saying that we're using the REST console or the REST API, run the delete method, connect. So it actually does it now, deletes everything. Finally, it closes the connection, and then it goes to on post execute. So on post execute, we just show the process is completed, and then we can test if this object that was now passed through, that E, if that E is not equal to null, then we know some exception occurred there. And then we can just maybe show that in a toast. So we could say e.getMessage to show that exception. And the else will be if everything went fine. So we can just say something like successfully deleted. And there we are. This is now everything we need. Okay, so now to delete the bulk from the backend, so let's just call it in this button there. So we will just say new delete bulk from backend dot execute, and that is doing it for us. Okay, so if we run this app now again, I'm going to leave this line there. So what this one will do then, it will create 300 objects for us again. So I'll just wait for that 300 objects to get created again, and then we'll try to delete them right from the app. So let's run the app quickly again. Okay, so the app is running again. Let's just go online to see if we've got that data there. So we're now at 39. So I'm just going to wait a bit for all 300 objects to get created online. Okay, so now we've got our 300 objects there in the table. So you can see there's all 300. In the REST console, if I click on delete now there, it will delete it. But we don't want to do it now from the REST console. Let's do it from the application. So from the application, I'm now going to say delete all person object. It says the process has been started. Please wait. Process is done, and it's successfully deleted, which means that if I refresh now, there should be 0 objects in the table person. So it's very important that you go to your REST console and first test to see if it actually deletes. Otherwise, in your coding, you'll also have a problem to actually delete it using this URL there. So that's basically how you delete then, or clear out a whole table. Now for the rest of this application, we need to retrieve more than 100 objects at once. So let's see how we're going to do that. I'm going to also create another async task to use or to help us in this. So again, we're going to create an async task, and I'm going to call this one private class get data in background. And we're going to say extends async task. And again, I'm going to do the same thing. I'm going to have void there. I'm going to have void there again. And this time I'm going to return a string. So we'll get to that string later on. So again, like any async task, we need to have the on pre-execute. Well, actually the only method you must have there is the do in background. But the on pre-execute and the on post-execute help us to do whatever we want to do. Setting up or showing the user the progress or whatever. And then on post-execute is the last one. Okay, so now the first step, let's go into the on pre-execute. So I've got to get data in background there. Okay, so let's go into the on pre-execute and just show a toast there again that we just saying we're starting something. Yeah, so I'm going to say process starting. Please wait. Okay, so that's basically in the on pre-execute, you start showing your progress dialog. Now in the do in background method, we're not accepting anything. That's what we said there. In that first void there, we're not accept anything. And the void there is there a progress bar that we need to update well, every time, or maybe every few seconds or whatever inside of the do in background. So we're also not going to use that, and we're going to return a string. That's what we return back. So what are we going to do in this do in background now? So the first thing that you want to do if you want to retrieve more data than 100 objects at a time is you need to see how many pages you're going to use. So in this case, if we've got 300 objects there, and the biggest pages, or the biggest page that I can actually get online is 100 at a time, then obviously I'm going to use 3 pages. So it's 100 objects, or there's 300 objects, but I can only retrieve 100 at a time. That's my page size, which means I can retrieve 3 pages. So the one thing that we need to get here is to see how many objects do we currently have in the database or in that table. So that's the first thing we're going to do. So we're going to say Backendless. Oh, I don't know what that one did now. Let's just go to Backendless .data.of, and then you're going to choose the class that you want to work with. So I'm going to go to the person class. That means basically the person table also online, and I'm going to call getObjectCount. And remember that we must always use the async callback. So I'm going to say new async callback, and that gets me the object count. So the object count there will then be saved in this response. So if our table has got 300 objects inside of the person table, that response will have 300, or will have the value 300. So I'm going to use a variable at the top there, and I'm just going to call that an int, and that will be number of objects. And then I'm going to use that variable now here. So I'm going to say that number of objects equals this response that we just had, and that is of type integer, which is the class integer, but it can also be saved as a normal int. Okay, and then we can also have a handle fault, but remember now, because we're in the do in background, I can't show a toast here showing that fault. So let's do something else this time instead of the exception object. So I'm going to have a string, and I'm going to call it errors. And if I go down, I'm going to set, where are we now? I'm going to set errors there. I'm going to say errors, maybe just before we start everything there in the do in background. I'm going to say errors equals just an empty string. And then I'm going to say errors equals the previous value of errors. And I'm going to add fault.getMessage to it. And let's just add a new line character there. So we're going to have all the errors in a new line. Okay, so that's basically it, getting the object count. So the object count will then be stored in number of objects. So now if we have the number of objects, let's say it's 300 there, we need to work out how many pages do I need to retrieve. So if you just look at this logically, if I have, let's say, 350 objects, how many pages will I have to retrieve? You agree that it cannot be only 3, because 3 would only retrieve 300 objects. So I need to have 4 if it's less than, or let's say between 300 and 400, I need to retrieve 4 pages. So in coding, how do we do that now? So after this, because that's the amount of pages that we need to retrieve, so I'm going to say int number of pages equals. And now the problem here is if I just say number of objects and I divide that by 100, basically what we'll get here, so let's just change that to 100 there. So basically what we'll get here is number of objects divided by 100. If there's 300 objects or 350 objects, I will get a 3.5 here. So I could also say, well, let's make this a double and the number of pages, but I mean, you can't have 2.5 pages retrieved. You must have either 2 or 3 pages retrieved. So there's another method here that will actually help us to get through this problem that we have here, to not get a comma value here. So I'm going to use what we call, from the math class, there's a ceiling, basically a ceiling method that will round up my value. So I'm going to say number of objects divided by 100.0. So let's say we've got 350 objects. Divided by 100 gives me 3.5. Then math.ceil will convert that 3.5 to a 4 and save that as an integer. And that's exactly what we want here. So if we've got 350, we divide it by 100, it's 3.5. So math.ceil will convert that to a 4, and we save that 4 back to number of pages. And what we can do now is now start basically retrieving, but we've got one very big problem here. And that is this piece of coding could still be busy in the background when we reach this line, which means that number of objects will actually still be, well, we can set it there to 0. So whatever it is there at the top, that's basically what I'll have here as the number of objects. Because this, to do this in background takes a lot longer than for the compiler to go from this line to that line to that line, which means number of pages will be 0 when we get to this line. And then after we are at this line, this part will probably stop running and we've got the number of objects, but now it's too late. So how can we correct this to basically force this part to execute first and then wait until it's done executing before we go to this line? Now there is something that we can use, and I'm going to declare it there at the top, and we call that a CountDownLatch. So you're going to use that class CountDownLatch, and I'm going to call this object latch1. I'm going to use a few latches now. So we're going to use a CountDownLatch, call it latch1. And then what I'm going to do here is just before we go into the back end there, I'm going to say latch equals new CountDownLatch, and I'm going to set the countdown to 1. So I'm going to try and explain this now. So I set the countdown to 1, and when I get into this part, as soon as it's done in the background, I'm going to say latch1.countdown. And then just after this, I'm going to say try with catch. And what I'm going to try and catch here is an interrupted exception. And what I'm going to do inside of the try block will be saying latch1.await. So basically what happens now is we set the countdown latch to countdown from 1. Every time I call countdown, it subtracts from 1 from that value there. So what we're going to do, we create the latch. Now it goes, after it's calling Backendless, it goes to the try and it stops right there. And it waits for that countdown to basically complete. So when that countdown is down to 0, this latch.await lets the code go beyond it. So I hope you understand this one. So we stop basically there. We're going to say this is the countdown latch. And when we call await, it will wait there. It will stop your execution of your user interface thread. It will stop it there, and it will wait until the countdown is back to 0 before it lets the rest of the code execute. Okay, and then in the catch one here, we're going to say errors. Oh, we're going to basically use this exact same line again. Will be the previous value of errors plus e.getMessage there. Right, so now number of pages will be 100% correct. Now before we carry on, I'm going to use 3 latches here. So I'm going to say latch 1, latch 2, and latch 3 to help me out. And right now, before we carry on to the next part, I'm going to create a new countdown latch again. So we've got the number of pages to be the number of objects divided by 100, and then taking the ceiling of that. So if we've got 350 objects, divided by 100 is 3.5. Convert that to a 4, and that's the number of pages. So I want to have the second latch here. Latch 2 equals new countdown latch. And this latch must be the number of pages that we're going to run. So let's say the number of pages will be, if we've got 300 objects, the number of pages should be 3. And we're going to retrieve 100 objects at a time and wait for all of them to get retrieved by using this countdown latch before we carry on. Okay, so what I want to do now is obviously we need an array list or something to store our data in. So I'm just going to quickly declare that one also. So I'm going to use an array list. Let's make it type person, obviously, and let's call it people, or let's call it data. Data there, and then if we go down to where we are currently at in our coding there, I'm going to say data equals a new array list, and this array list is of type person. Okay, so that's just setting up the array list. And now we can start getting data from Backendless. So if you remember, we need a query builder. So I'm going to just declare a query builder there at the top. So it's going to be data query builder. And let's call it query builder. And then I'm going to go down again. Where are we now? We are here. And then I'm going to say that query builder that I've just declared should be data query builder dot create, just to set up the query on the data that we want to retrieve here. But now I'm going to do this a bit different, because I'm going to run a for loop for the amount of pages in order to basically get all the pages, which is 100 pages or 100 objects per page. Okay, so let's see how we're going to do this. So we're going to say, I'm going to start with an offset of 100, and I'm going to explain now why I start with an offset of 100. Now I'm going to run the for loop, and I'm going to say integer I equals 0, starting from position 0, I less than the number of pages. So if we've got 300 objects, divided by 100 gives me 3 pages, and I need to run this for loop 3 times, and every time I run it, I want to retrieve 100 objects at a time. Okay, and then I++ there. Remember that the maximum amount of objects you can retrieve at a time is 100. That's the maximum page size. So in the for loop, let's set up that query builder now. So I'm going to say query builder dot set where clause, and let's say the where clause should be where the surname is not null. Okay, so that's one that you can say. So basically we retrieve all the objects because all the surnames are not null. And then I'm going to say query builder dot set page size, and the page size will be 100, so we can get the maximum number of objects per page. And then I'm going to set the offset, and I'm going to set the offset now as offset, but I'm going to multiply this by the I of the for loop. Now let's see how that will work. So the very first time the for loop runs, you will see that the offset, which is 100, multiplies by I, which is 0. So in effect, we're setting the offset to 0 to start right at the beginning. When the for loop runs again, after retrieving 100 objects, that one will become 1. And the offset then will be 100 times 1, which means we start retrieving from object 100. So I hope you see how this one is working now. So I'm going to say query builder dot set sort by, and I want to sort this by that new field that we created, which will be the number field. So we can see all that objects in sequence to see if we've actually got all 300 of them. Right, so the next part I'm going to do here is to now basically go into the background, but for that I want to use a third latch there. So I'm going to say latch 3 equals new countdown latch, and that countdown latch will also be just 1, and I'm going to explain that one right now. Remember that we also set latch 2 to be the number of pages, and now I'm setting a latch 3 there, but I'm going to explain that one now. So we're going to go to the back end now. So we're going to say backendless.persistence.of, and then you need to indicate the class. This is the person class again. And we're going to say .find and pass in the query builder, just like we did in the previous video. And we're going to say new async callback. And that opens up this whole thing for us. So it will go down, it will set the page size to 100. It will, when the loop runs the first time, the offset will be at position 0. And after this, in handle response, we've got the first 100 objects. So in this part, we need to now run a for loop again, just to set the data that's in this response to our array list. Now, I can't just say data equals response, because there's more than just this 100 objects. So what I'm going to do in the for loop the whole time is to just keep on adding to data to get all 300 of them. So I'm going to say in this for loop, integer I equals 0, I less than response dot size, and then I'm going to say I plus plus. Right, so that's the for loop that we're going to run through every element that we got, and that should be the first 100 objects. And every one of that 100 objects, we're going to say data dot add. And what I want to add here is the following. I'm going to say response dot get I dot get number, and then I'm going to add a space, or not a space, let's make something like that, and then we're going to say response dot get I dot get surname. So we're going to show the number first, then the guy's surname, and then we'll have, let's say, a comma, and then response dot get I dot get name. So it's the surname and then the name. Just see why this one gives us an error. Okay, so the error here is because we've got a person array list here, and I think I want to have that one a string. So let's just go to the top and make that one a string. So what I want to do is to basically set this one later on to a list view, to that list view of ours. So where are we now? There we go. Okay, so this one is fine now. So data.add, I'm adding the number, then this get the surname, and then a comma, and then the name. And that's what we're going to show in the list view. So it will be the number, the guy's surname, and then his name. So in this for loop now, we are basically creating the data for that array list, retrieving all 300 of them. So obviously, the first time the loop runs, we're going to get the first 100 and add them to data. The second time it runs, we get that I becomes a 1 times 100, and we also retrieve 100, so that's the next 100. So that will be up until 200. Then I becomes 2 times 100 will be 200. That's where we start, and we retrieve the last 100. And every time we're adding that data, or the data from the response there, which is a list of person objects, we get that data and we add it to the data array, our data string array. Okay, then after this for loop, we're going to go to the query builder again, and we're going to call prepare the next page. So it will be prepare the next page for us. But now remember, this one could actually now run already before we've got this first 100. So we must stop that one as well. And that's why we've got all of these latches now. Because this for loop will, if I don't stop the for loop to wait for a specific backendless persistence to come back, all three of them will run at the same time. And it could happen sometimes that even though you're calling this one, then the next one, then the next one, one of them could maybe go faster than the other one, or the connection is just a bit slower at a specific position in it, and then you don't get them in sequence. And remember, we are sorting them while we're doing this. So it's imperative for us to have this first one done and added to data, then the second one done, added to data, and then the third one done and added to data. So if we want to have that happen, we need to stop it a bit. So I'm going to say latch 2.countdown here, but I'm also going to say latch 3.countdown. dot countdown. And I'm going to go through these latches again, so just to make sure that everyone is on track there. So we're basically going to say latch 2 dot countdown and latch 3 dot countdown, which will stop both, or which will count down both of them. Remember, latch 3 is only at 1 there, but every time the for loop runs, we set it to 1 to basically let this thing wait before we can carry on. So after this backendless call, then we'll have that wait. So we're going to say try and catch, and we're going to catch that interrupted exception again, and we can have that same errors part there again, just e.getMessage. And then in this try now, I'm going to say latch 3 dot await. So that's the one that should wait now. So basically, when the for loop runs, we've got latch 3 at a countdown of 1. Inside of this, only when it's done, we count down latch 3. So you can see that when we wait there, we wait basically before the for loop runs for the second time until this countdown is back to 0. So there we set the latch to 1. When it's done in the background, we count down to 0, and then it will go after this line, which means the loop will run again. Okay, so you can see now that we will have the first part run first, then the second part run, and then the third part run. We won't get that situation where one of them could run faster than the other one and we don't get our sorted data. But if you want to run it a bit faster, you can remove this latch totally, but then I will remove also the sort by there, and then you sort it yourself. So it's up to you what you want to do there. Okay, so now then after the for loop, if the for loop is done now, then we need to stop the other latch. So we're going to say try, catch, and this will also be an interrupted exception again. And I'm going to have that same errors again. And then we're just going to say in the try block, we're going to say latch 2 dot await. Now let's just quickly have a look at latch 2 there. So latch 2 is there right at the top. So the first latch there, remember that's to get the object count. So we set up the latch. When we are done retrieving the object count, we do the countdown from 1 to 0, and then it can go past this line. Then we set up latch 2 after getting the number of pages. We set up latch 2. Latch 2 starts at the number of pages. Let's take our example, 300 objects. So that will be 3 there for latch 2. So latch 2 starts there. In the for loop, we count down the latch, and you can see the latch will be the number of pages, which is also the number of times that specific for loop runs. So every time the for loop runs, we count down this latch. So you can see latch 2 dot countdown. And as soon as all 3 of them in the for loop is done, only then will we go past this line, and it will go to the on post execute. Okay, so I hope you understand the countdown latches here and how it helps us a lot in this example. Okay, so now for the last part here, we're just going to say basically, so we got the string that was passed through, and I'm going to need to pass the errors here as a return part there. So inside of your doInBackground method, the last return type there must be our errors. Let me just see if I've got all the errors there. There's another error that can occur. Have we got all of them now? Yes, it seems so. Okay, so then in the on post execute, we can go and test if that S there that was passed through, which is this errors, if the S that was passed through, let's say dot equals, and let's say not equals. So if it's not empty, remember that we have declared it empty at the top, just an empty string. So if it's not empty, it means that we've added something to it. So we've got an exception there, and we can show that exception. So we can just say the following errors occurred, and then we can just show maybe a new line first, and then show that S. And maybe we should also make the short long there, to maybe show it a bit longer there. And then the else part will be, well, everything actually went fine, and we can show a toast to just say process complete. Okay, and this is now where we can set up our array list now to the list view. So I'm going to say create a new array adapter, and this array adapter will be of type string. And remember, in previous videos I've shown you how to create your own array adapter and how to create your own custom list view. So in this one is just using one of the predefined array adapters. So I'm going to call this one array adapter equals new array adapter. And then the first argument will be the main activity dot this, that's the context. The second argument will be how your row items will look like. And for that, I'm going to use from the Android libraries, I'm going to use from there R and droid.r.layout.simple list item 1. That's the one I'm going to use. So it's just a simple list item. It's basically just one line, one string per item. And then the last argument there is your array list that you're going to set to it. And then after this, we're just going to say that LV data of ours, which is the list view, I'm going to set the adapter to be this array adapter. Okay, so I'm going to save now. And I think that we are done with this part. So let's, in the get data in background, that's the name of the class. So let's go to the button to retrieve the data. And we're going to say new get data in background dot execute. We said void there, so we're not passing in anything, and that should be it. That should be done. Okay, so I hope that everything is 100% now. So let's run this quickly. And remember, by running this now again, we will get that 300 objects created online. So we'll see now as soon as it runs. Okay, so there it's running now. So if we go online quickly before I call that retrieve method, let's just refresh quickly. And you can see it's busy creating all of the objects for us. So I'm just going to wait again until we get to 300 objects there. Okay, so there we are, 300 objects now. So let's retrieve those 300 objects now. So remember, I started naming them or numbering them from 1 to 300. And we said we should sort it by that. So if I click on retrieve more than 100 objects, process starting, please wait. Take some time in the background. And because we're getting 3 different pages here, it takes a bit longer than just retrieving that first 100 objects. So you can see there's all my data. There's 1, 2, 3 up until 10. And the first page will go up until 100. And there you can see. And then we've got 101 and so forth. And then there we start with the 200s. And we should stop at 300 there. So now what could happen, remember that I told you this part there for latch, where was it? Latch 3. So let's remove this latch 3 quickly. And I'm going to remove the countdown there. And let's just remove all of these as well. Okay, let's see how that one works now. So if we leave that one there, and I'm going to run this quickly again. Unfortunately, now when we run it again, we're going to have doubles actually in the application. So I think let's use the application to quickly delete all person objects for us, which will now delete and make sure that we clear out all the objects. And then if I retrieve now, you will see basically when it's done, we won't see anything because there's no objects at all. So you'll see the list is empty now. There's no objects at all. So I'm going to quickly run this app again. So I'm just going to close it down. Let's run this application again. And this application will then create that 300 objects for me again. And now with the change code, leaving out that latch there, sometimes if you're lucky, it will actually retrieve exactly the same things that we had now. which will be fine. So I'm just going to quickly check there if we've got the 300 objects already. So we're still at 81. So I'm just going to wait to get that 300 objects again, and we can continue. Okay, so there we've got 300 objects. So if we go now to the app, and I'm going to say retrieve more than 100 objects, so there the process starts, and it's done. So let's just go and see. You'll see the first 100 will definitely be sorted correctly. And then you can see there's the problem now. So you can see there from 100 we jump to 201. And you'll see from 201 it is sorted again for that page, which is 100 objects. And it's sorted again for up until 300. And then it starts at 101. And then 101 up until 200 will be sorted again. So you can see the problem here. The whole thing is not sorted because from 300 we go to 101. It's not sorted. Why is that? That's because of this latch that we left out now. So this latch helps us to get a countdown latch there, do the countdown there, and then wait for that countdown to complete. So it's going to stop the coding here. And what is the coding stopping? It's stopping the for loop from running again until we've got the data added to the data array list. So if it's done there, only then it says latch3.countdown. So we will never get to that process where maybe we're running the first one and then we run the second one. And when we run the second one actually completes before the first one. That's the problem that we've got currently. Okay, so that's why we use the latch to make sure that we stop there, stop the loop from executing again until we get to this line where it counts down from 1 to 0, and then we can run the for loop again, and then we'll get it sorted. So I'm going to run this again, but before I run that, let's just delete all of these objects again. I'm going to execute a delete there to make sure there's no objects. And let's run it again. Let's run it on the device. Okay, so now it's busy creating those objects again. So I'm just going to wait a bit for all of those objects to actually get created again, all 300 of them, and we'll continue. Okay, so there we've got the 300 objects again. So let's run this application again. If I say retrieve more than 100 objects now it takes a bit longer now. You'll see it takes a bit longer because we're forcing it to stop and wait to get our sorted data. So if I go down then, you'll see from 100 it goes correctly to 101. So we waited for that list to get inserted before we go to the next one or the next page. And from 200 to 201, and then we stop at 300. So now it's working 100%. And again, we can delete from here. I can click on delete all person objects, process is complete, and now if I try to retrieve those objects, you'll see my list will then be empty. So that is basically deleting person objects and also retrieving more than 100 objects. And remember, the most that you can retrieve, or the most objects that you can have in your table, is 1000 on the free plan. And that means that you won't have more than 10 pages on the free plan that you need to collect. And obviously, the more the pages, the more the objects, the more API calls you use, because for every one of these, we're using an API call. So let's just go through that. We use an API call here to get the object count. And then for every time this for loop runs, we're using an API call. So just keep that in mind. If you've got 1,000 objects that you need to retrieve from the backend, it means that you're going to use 10 API calls to do that, plus the one that you used in order to get the object count. So in fact, you'll be using 11 API calls. I hope you've learned something from this video. Until the next one.